Page 97. All right, so how do we deal with relativistic velocities as they relate to the expansion of the universe? That's what we're going to talk about here. And so there are going to be a few more formulas I'm going to throw at you. They're pretty straightforward. They're pretty much, plug and chug sort of formulas. But the pieces and parts are here on page 97, where V is expressed as a fraction or a decimal of c. For example, a quarter of the speed of light would be referred to as 0.75 c. We've talked about that before. C is the speed of light. And then we see lambda with that little subscript. That's called lambda naught. Lambda naught is the original wavelength. Lambda is the changed or shifted wavelength, as in redshift or blue shift. Delta lambda is the total amount of wavelength shift. We just subtract lambda from lambda. We subtract lambda naught from lambda. And Z is the amount of redshift. And the formulas that we have here, Z equals lambda minus lambda naught over lambda naught, which equals delta lambda over lambda naught. Boy, that's quite a mouthful. And Z also equals velocity over c. So that's another way of expressing speed of relativistic velocities. And V equals Z times c. Now, if Z winds up being less than 0.1, remember, we talked about this way back. If Z is less than 0.1, then velocity is non-relativistic. Write that in there. Non-relativistic. So that's a lot of stuff. So take a moment if you want to hit pause and kind of digest all this, that's fine. All right. So let's go to an example. And again, this is the sort of thing where examples are the best way to get a handle on it. So this first example here, astronomers on Earth observe a distant galaxy and they measure a visible light wavelength of the element sodium at 401.8 nanometers. So in other words, lambda is 401.8 nanometers. Normally, sodium emits a line of visible light at 393.3 nanometers. So lambda naught, the original wavelength, is 363.3 nanometers. And let's see. Yeah. Oh, that's a typo there. Okay, so that second one where it says 363.3 nanometers, cross that out and write in 393.3 nanometers. Okay, so again, that's what happens when you don't have an editor. Okay, so what we want to determine is if the wavelength is redshifted or blue shifted. We want to determine if the galaxy is approaching or receding from Earth. And we want to determine the velocity of the galaxy relative to Earth. So, using our formula, Z equals lambda minus lambda naught over lambda naught, which is the change delta lambda over lambda naught, which will come out to 401.8 times 10 to the negative 9 minus 393.3 times 10 to the negative 9 over 393.3 times 10 to the negative 9. If you bash that out on the calculator, that comes out to 8.5 times 10 to the negative 9 over 393.3 times 10 to the negative 9 The powers of 10 cancel out. 8.5 divided by 393.3. That comes out to 0.022. So our velocity is 0.022c. And that is definitely non-relativistic. That's a non-relativistic velocity. It's well below 0.1c. All right, we'll pause here and go to the next page.